Hi everyone, and welcome to today's lesson on writing algorithms. In this video, we're going to learn how to plan and write algorithms using something called pseudocode. This is part of our Introduction to Python series, and by the end of this video, you'll have a better understanding of how to think like a programmer. Let's dive in. Before we get started, let's talk about what we're going to learn today. First, we'll learn how to write algorithms using pseudocode. Pseudocode is like a rough draft of your code. It helps you plan what you want your program to do. Second, we'll look at different types of errors that can happen when you're programming, like syntax errors, runtime errors, and logic errors. Don't worry if those terms sound confusing right now. We'll explain them as we go along. Ready? Let's move to the next slide. Okay, let's start by looking at an example of an algorithm. This one is called Dragon Quest, and on your screen you can see what it looks like. So what does this algorithm do? Maybe pause the screen for a moment and have a look at the algorithm again. Right, now let's go through the answer. Well, first, it checks if the dragon catches the knight. If that happens, the knight's health decreases by 1. Then it checks if the health has reached 0. If it has, the game ends with you lost. If the knight still has health left, it displays run away to show that the knight is still in the game. This is a simple example of how algorithms work. They use conditions like if to make decisions based on what's happening in the program. It's pretty cool, right? Now that we've seen an example of an algorithm, let's talk about pseudocode. Pseudocode is a way to write out your ideas in a format that's similar to code, but it's not actual programming language. It's like a mix of English and code, and it's really helpful for planning your programs. Here's why pseudocode is useful. It doesn't have strict rules, so you don't need to worry about syntax. It uses programming concepts like loops and conditions, but in a simpler way. It helps you think through your algorithm before you start writing real code. So always remember, plan with pseudocode first, then write your actual code. It'll save you a lot of time and frustration as well. When you're writing pseudocode, there are some common words and phrases you can use to make it clear and easy to understand. Here are a few examples. Use words like input, print, or show output to show when the program is taking input or showing something on the screen. Use words like compute, add, or assign to describe actions the program is performing. Use if, then, else, and if to describe decisions the program needs to make. Also, don't forget to use indentation. That's when you space things out to show which parts of the code belong together. It makes your pseudocode much easier to read. Let's look at an example on the next screen. In this example of pseudocode, we can see that it's for a login system. Let's break this down. First, the program checks if the start button is clicked. If it is, it shows the login screen and asks the user to input their username. Then, it checks if the username is valid. If it is, access is granted. If not, it displays invalid username. and lets the user try again. If the Start button isn't clicked, the program just shows the home screen. This is a great example of how pseudocode helps you plan out the steps your program needs to take. You can see how the conditions and actions fit together, even though it's not real code. You can see on your screen a summary of what this example pseudocode does. If you missed any of the explanation, consider pausing the video just to have a reread of what this pseudocode is actually doing. Okay, let's talk about something every programmer deals with: errors. There are three main types of errors you'll encounter when writing code. Syntax errors. These happen when you make a mistake in the structure of your code, like forgetting a colon or a bracket. The computer won't understand what you're trying to do, and your program won't run. Runtime errors. These happen while your program is running. For example, if your program tries to divide a number by 0, it will crash because that's not allowed. Logic errors. These are the trickiest because your program will run, but it won't do what you want it to do. For example, if you write an algorithm to add two numbers, but accidentally subtract them instead, that's a logic error. Don't worry if you make these mistakes, everyone does. The important thing is to learn how to find and fix them. That's it for today's lesson on writing algorithms. I hope you enjoyed learning about pseudocode and the different types of errors. Remember, practice makes perfect, so don't be afraid to try writing your own algorithms and pseudocode. If you have any questions, leave them in the comments below, and I'll do my best to help. Thanks for watching, and I'll see you in the next video. Bye for now.